The question is x plus 5 over x minus 2 is greater than or equal to 0. And we're asked to solve. So the first thing that we do when we're asked to solve an inequality is that we want to make sure that there can never be a number that will make the denominator of our question a 0. So if we take x minus 2, it's very easy for us to look at this and see that our answer is going to be 2, because if we did 2 minus 2, that equals 0, and our denominator can never be a 0. So our first answer is 2. The next thing we want to do is solve for a related equation. Now the way we do that is that we take the equation, same as it is now, x plus 5 over x minus 2, and this time we put an equal sign in between instead of the inequality. And then we solve. Now we know that the way that we get rid of an equation is that we have to multiply both sides, we get rid of a fraction in an equation, we have to multiply both sides by the denominator. And when we do that, it cancels out over here, which leaves us with x plus 5. And over here we have 0, so it doesn't matter what we multiply to, we have equals 0. And then when we solve for x, we get negative 5. So we also have x equals negative 5. If we plug that in, it would also give us 0 in the numerator, but we know that it's okay to have 0 in a numerator, so that's that. Now what we want to do is take a timeline and we want to plot our points. So we have negative 5 here. For the sake of continuity, we'll just toss in a 0 here, and we have 2 here. And now we want to split this up into regions. So we now have a region that comes all the way from negative infinity all the way up to negative 5. We have another region that runs from negative 5 all the way up to 2. And we have a region that goes from 2 all the way to infinity. We're going to go ahead and call these regions A, region B, and region C. Now what we want to do is make a test point. And what we can do is pick any number between negative infinity and negative 5 and test it in our equation to see if it's true or false. So in this case, I'm just going to pick negative 8 because we know that negative 8 is between negative infinity and negative 5. So we have negative 8 plus 5 over negative 8 minus 2 greater than or equal to 0. Negative 8 plus 5 is negative 3, negative 8 minus 2 is negative 10, and that gives us 3 over 10 greater than or equal to 0. So is this a true or false statement? 3/10 is greater than or equal to 0 is true. So our region A is part of the solution set for this inequality. Now, because 0 is between negative 5 and 2, let's go ahead and use that as our test point for region B. So we have 0 plus 5 over 0 minus 2 greater than or equal to 0, which gives us 5 over negative 2 greater than or equal to 0. Negative 5 halves is negative 2 1/2 greater than or equal to 0. So is it true or false that negative 2 1/2 is greater than is greater than 0? And the answer is no, it's not, it's false. And so the whole entire region of our region B is not going to satisfy the answer for the inequality that we have here. One last region that we'll test, we can pick any number between 2 and we can't pick 2 though, right? Because if we picked 2, that would leave us with a 0 in our denominator. So any number above 2 all the way to infinity. And if we do that, we can test it. I'm just going to go ahead and pick 8. So we have 8 plus 5 over 8 minus 2 greater than or equal to 0. 8 plus 5 is 13. 8 minus 2 is 6, greater than or equal to 0. 13/6 is 2 1/6. So we ask ourselves, is 2 1/6 greater than or equal to 0? The answer is true. So we now have another region that satisfies the inequality. Now we just have to write this in a solution set. So we have true, false, and true. So false is not going to be a part of our answer at all. So we have negative infinity all the way up to and including -5. And that's because it's okay if -5 were plugged in for x here or -5 were plugged in for x either in our numerator or our denominator. It would still give us the correct answer. So we do include -5. Then we want to use the union sign because remember, union means that our answer belongs to either set. We don't have anything in common in these in A and C, and so we use union there. And then we're going to go ahead and put a parenthesis here because we can't include 2 in our answer. So up to but not including 2. So we're going to have 2 comma infinity with another parenthesis, of course. We always use parentheses on our infinities. So our final answer is negative infinity to -5, up to and including, so we use a bracket, then union, then 2 comma infinity. Both of those we use parentheses because we cannot include 2 in the answer.